Hello everyone. In this video, we will see how Anuta ATOM can be used to automate L3 VPN services in your network. For this, we will utilize ATOM service models that are based on Yang. What we are seeing on the screen is the L3 VPN service model. This is inspired from the IETF RFC for L3 VPN, but few modifications have been made for easier consumption. The design of the service model is such that the Yang module is divided into two main containers, VPN services and sites. So the first step is to create a VPN service. The VPN service is a service level view, and under the VPN services we will create VRFs. It has details such as VPN ID. We also have the service topology, which we've selected as any to any. In the VPN nodes, we will configure the devices involved in the service. So here in the VPN node 1, we have the RD values for route distinguisher for this device, the device IP, and the node role will be any to any. The VPN targets has the corresponding RT values. Similarly, a second VPN node can be created for the other devices involved. Before we apply this part of the configuration, let us verify that the device has no L3 VPN configurations in it. The device we are using is a Juniper MX device that supports native Yang. As seen here, there are no L3 VPN configurations on this device. Now let us apply this configuration. ATOM will now generate netconf payload and apply it to the device. Here we can see the VPN service netconf payload that ATOM has applied on the device. On the device, we are now able to see the relevant configurations. The next step is to create a site. A site represents a connection to a customer office to one or more VPN services. It basically contains information regarding detailed implementation arrangements made with the customer or peer operators at each interconnect location. The main attribute in this template is a device that we will use. Let us activate it. However, in this case, ATOM does not generate any commands for the site container. Similarly, we can create another site for the second device. Under the site, we have the site bearer, where we give the physical port or the LAC details. Like in the case of the main site container, ATOM does not generate any commands for site bearer as well. Similarly, we can create another bearer under the second site for the second device as an example. Then we have the site network access container that defines the bearer, the type of connection, and other service parameters. This is also the container that links the physical bearer and the service together. As seen here, the VPN service created earlier has been referred as a service ID. It also has the device IP in that particular site and the type set as point-to-point. The subcontainer bearer has the bearer details we created under the site and the port ID that will connect to the key device. The connection has the encapsulation details and the tagged interface, which is .1q, the tag type set to CVLAN along with the customer VLAN details. The IP connection subcontainer has the provider address and the customer address. The routing protocols supported are static, BGP, and OSPF, and each of its details can be configured in the relevant settings. Now once we trigger this model, ATOM will generate the corresponding netconf payload for the device. As you can see on Atom, the netconf payload corresponding to the configuration is generated and provisioned on the device. The payload shows the details of how the VPN service and the physical bearer has been stitched together. The routing protocols and its related configurations can also be seen here. The same can be verified on the device as well. As seen here, Atom has provisioned an L3 VPN on the Juniper MX device. Similarly, the other devices involved can also be configured to complete the service. Thanks for watching.